Hello, everyone. This is Group 10, and we are going to talk about our approach for the stock market prediction problem. This is Prakarsh, Swathi, Adnan, and Madan. The problem description, we want to predict stock prices, but stock prices are volatile in nature, and they depend on various factors around the world, such as political events, and microeconomic, macroeconomic factors, and so forth. But we can use time series forecasting and modeling, such as ARIMA, to fit the time series to this data, which contains the stock prices along with the other microeconomic indicators as inputs. Such a model would then predict the closing price of stocks in the Nasdaq 100 index for every trading day from December 5th to December 9th, according to the challenge. And based on these predicted stock prices, decisions can be made which maximize our profits. In our approach, we model stock prices as an autoregressive moving average time series, ARMA. Particularly, we use the ARIMA formulation, the integrated formulation, to incorporate the differencing operator for addressing the trends that would exist in the data. And we considered the prices as regressants and auxiliary information as regressors. We use the stats model library to implement the ARIMA for a given company. So we had 100 different models, one for each company. And then by using the best ARIMA PQD formulation, we predict prices of stocks from December 5th to December 9th. And then based on these, we select the optimal trade using dynamic programming. Finally, we incorporate a notion of uncertainty in our predictions through the variance of the prediction that we have generated. And then finally, we use this variance adjusted predicted profit for selecting and ranking the top 3 trades.
So let's get into the data set. We contain the closing price, and then we pair it with the economic factors of that company. So that includes revenue, income, earnings before taxes. And these, along with the closing price, are collected since 2003. And it is built in such a way to find the relationship between these factors and the price.
So for the time series modeling, say, for instance, for a given company like Apple, we fit the ARIMA model to its price history, but we exclude the most recent 5 days. And we use these 5 recent days as the test for the parameters because we do not have the actual labels because we're predicting the future. And by using the predicted model, by fitting the ARIMA models, we predict the prices for these excluded days to compute the error with them. And the different parameters for ARIMA that we explore are ranging from ARIMA 111 to ARIMA 533. And we select the best performing model that has the least error with the 5 held out days. Then once we have obtained the best ARIMA parameters, we refit the model to all of the data, including the 5 days that we'd held out before, to generate the predictions that would then be used by the dynamic programming model.
So let's get into the stock recommendation engine. As Prakarsh said, we already do the regression. That's the last stage is to compute the best profit. So what we do is we find the optimal short and long transaction using dynamic programming and use the variance as an uncertainty measure. So you can go to the next. The results we get between 0.035 and 0.01 error. And at the end of our predicted trades, we predicted a $23 profit via a short transaction, which matches the Nasdaq performance of negative 3.31%, because when there's a negative dip, you want to do a short transaction. And you can see in the results here, we have between 0.01 to 0.035 or 0.04 error. The future work, we would like to incorporate the hidden Markov model and Kalman filter to do the optimal trade selection, because that includes the posterior likelihood. And we would also like to have better ways to validate the PQD via stationary and extra validation tests. And the last thing we would like to do is use the web. There's so much data on the web, so we can use web scrapers to get the web chatter about a stock and use that in our model. So that is it for our presentation, and thank you.